crushed hands and arms, severed fingers, blindness. The list of possible machinery-related injuries is as long as it is horrifying. Safeguards are essential for protecting workers from needless and preventable injuries. A good rule to remember is this: any machine part, function, or process which may cause injury must be safeguarded. Where the operation of a machine can injure the operator or other workers, the hazard must be controlled or eliminated. Employers are responsible for providing the proper machine guarding on all machines and training employees on how to handle machines safely. Employees are responsible for ensuring that machine guarding is maintained and completing the proper machine guard training. The most common causes of machine accidents are reaching in to clear equipment, not using lockout, tagout procedures, unauthorized persons doing maintenance or using the machines, and missing or loose machine guards. All parts of the machine which move while the machine is working can cause mechanical hazards. This includes flywheels, pulleys, belts, couplings, chains, cranks, gears, feed mechanisms, and auxiliary parts. The point of operation is the point where work is performed on the material, such as cutting, shaping, boring, or forming of stock. The point of operation must be guarded. All rotating parts should be effectively guarded. In-running nip point hazards are caused by the rotating parts on machinery. There are three main types of in-running nips. Parts can rotate in opposite directions while their axes are parallel to each other. These parts may be in contact, producing a nip point, or in close proximity to each other, where the stock fed between the rolls produces the nip points. This danger is common on machinery with intermeshing gears and rotating cylinders. Another type of nip point is created between rotating and tangentially moving parts. For example, a chain and a sprocket, a rack and pinion, or the point of contact between a powered transmission belt and its pulley. Nip points can also occur between rotating and fixed parts, which create a shearing, crushing, or abrading action. For example, spoked hand wheels or flywheels, screw conveyors, or the periphery of an abrasive wheel and an incorrectly adjusted work rest. A good safeguarding system eliminates the possibility of the operator or other workers placing parts of their bodies near hazardous moving parts. A safeguard that can easily be made ineffective is no safeguard at all. Guards and safety devices should be made of durable material that will withstand the conditions of normal use and be firmly secured to the machine. A good safeguarding system protects against falling parts. A small tool which is dropped into a cycling machine could easily become a projectile that could strike and injure someone. A safeguard defeats its own purpose if it creates a hazard of its own, such as a shear point, a jagged edge, or an unfinished surface which can cause a laceration. The edges of guards, for instance, should be rolled or bolted in such a way that they eliminate sharp edges. The safeguard must not prevent the worker from performing the job quickly and comfortably. If possible, a worker should be able to lubricate the machine without removing the safeguards. The following are examples of different types of guards you might encounter. A fixed guard provides a permanent barrier and encloses the danger area. A fixed guard is preferable to all other types of guards. When an interlocked guard is opened or removed, the tripping mechanism and/or power automatically shuts off, and the machine cannot cycle or be started until the guard is back in place. An adjustable guard provides a barrier which may be adjusted to facilitate a variety of production operations. Adjustable guards are useful because they allow flexibility in accommodating various sizes of stock, but because they require adjusting, they are subject to human error. A self-adjusting guard provides a barrier which moves according to the size of the stock entering the danger area. A pullback device utilizes a series of cables attached to the operator's hands, wrists, and/or arms, and is primarily used on machines with stroking action. A pullback device allows access to the point of operation when the slide or ram is up, and withdraws hands when the slide or ram begins to descend. A restraint device uses cables or straps attached to the operator's hands and a fixed point. The device must be adjusted to let the operator's hands travel within a predetermined safe area. Hand-feeding tools are often necessary if the operation involves placing material into the danger area. A safety tripwire cable is a device located around the perimeter of or near the danger area. The operator must be able to reach the cable to stop the machine. Tripwire cables must be manually reset to restart the machine. A two-hand control device requires constant concurrent pressure to activate the machine. The operator's hands are required to be at a safe location and at a safe distance from the danger area while the machine completes its closing cycle. A gate is a movable barrier device which protects the operator at the point of operation before the machine cycle can be started. If the gate does not fully close, the machine will not function. Locate the machine or its dangerous moving parts so that they are not accessible or do not present a hazard to a worker during normal operation. Always maintain a safe distance from the danger area. A protective shield does not give complete protection from machine hazards, but does provide some protection from flying particles, splashing oils or coolants, and may provide the operator with an extra margin of safety. Holding tools are used to place and remove stock in the danger area. These tools are not to be used instead of other machine safeguards, but as a supplement. Here are some examples of OSHA machine guarding requirements. When the periphery of the blades of a fan is less than 7 feet above the floor or working level, the blades must be guarded with a guard having openings no larger than ½ an inch. Work rests on offhand grinding machines must be kept adjusted closely to the wheel with a maximum opening of 1/8 of an inch to prevent the work from being jammed between the wheel and the rest, which may result in wheel breakage. The distance between the wheel periphery and the adjustable tongue must never exceed 1/4 of an inch. A power transmission apparatus, such as shafting, flywheels, pulleys, belts, or chain drives, that is less than 7 feet from the floor or working platform must be guarded. To review, the employer must ensure all machinery is properly guarded. Supervisors must train employees on specific guard rules in their areas, ensure machine guards remain in place and are functional, and immediately correct machine guard deficiencies. Employees must never remove guards unless machine is locked and tagged. Employees are also required to report machine guard problems to supervisors immediately and must never operate equipment unless guards are in place. Machine operators should be trained on the hazards associated with particular machines, including how the safeguards provide protection and the hazards for which they are intended, how and why to use the safeguards, how and when safeguards can be removed and by whom, and what to do if a safeguard is damaged, missing, or unable to provide adequate protection. In summary, Safeguards are essential for protecting workers from needless and preventable machinery-related injuries. The point of operation, as well as all parts of the machine that move while the machine is working, must be safeguarded. A good rule to remember is this: any machine part, function, or process which may cause injury must be safeguarded. This has been a production of Federal Safety Solutions. For more information, please visit fssamerica.com.